So let us discuss. I already have discussed about logarithmic functions. Okay. Today we are going to discuss about graph of logarithmic function. So what is the graph of logarithmic function? If you consider any point PQ on the graph of y is equal to a to the power x, we have q is equal to a to the power p. So we have p is equal to log q to the base a, or there is a point q comma p on the graph of y is equal to log x to the base a. Thus for any point pq on the graph of y is equal to a to the power x, we have a point q comma p on the graph of y is equal to log x to the base a. Since point q comma p is the mirror image of the point p comma q in the line y is equal to x, we can draw the graph of y is equal to log x to the base a by taking the mirror image of the graph of y is equal to a to the power x in the line y is equal to x. Thus graphs of y is equal to a to the power x and y is equal to log x to the base a are symmetrical about the line y is equal to x. So y is equal to e to the power x and y is equal to log x to the base a, both are symmetrical about the line y is equal to x. And this y is equal to x line will be just from the middle, it will go crossing both the axes with the equal angles. So when a is greater than 1, from the graph we can see that y is equal to is an increasing function in this domain. The value of log x to the base a approaches to infinity. As x approaches to infinity, the value of log x to the base a approaches to negative infinity. As x approaches to 0, also x2 is greater than, we have log x2 to the base a is greater than log x1 to the base a. When a lies between 0 and 1, in that case y is equal to e to the power x. We can say that the y is equal to y is equal to log x to the base a is decreasing. The decreasing function is to make the value of log x to the base a approaches to negative infinity. As x approaches to infinity, the value of approaches to positive infinity as x goes to 0. Log x2 to the base a is less than graph of logarithmic function for different bases. Now this is the graph for logarithmic function of different bases, that is y. So we have gone with y is equal to log 0.2 to the power of x, log x to the base 0.2, log x to the base 0.5, 4, 2, e. All the graphs are different here. Common logarithm is the logarithm with the base 10. It is known as decadic logarithm named after its base. It's negated by log 10 to the base log 10x. Actual logarithm is the logarithm to the base e, where e is an irrational constant equal to this much. E is equal to limit m tends to 0, 1 plus 1 by m whole to the power of m. The natural logarithm generally written as ln x or log x to the base e. So there are a few things. Okay. Let us write few things here. Common logarithm base 10 decadic logarithm. Decadic decadic logarithm. Okay. Decadic logarithm. So it is example is log x to the base 10. Okay. Natural logarithm the base is e, and we can say that e means limit m tends to 0, m tends to infinity, 1 plus whole to the power of m, written as ln x or log x to the base e. So till here we have reached.